Alright guys, so last time we did this entire table and figured out these two very important aspects. The aspect is that there will be 4 things we need to consider, which we have not done so far. So our 2 known hand, our 2 unknown hand, the table, and unknown table. So let's go ahead and do that. Therefore, here what we have is a pre-deck of 0s and 1s. This pre-deck is basically prepared beforehand, and we will need to work with this deck in order to figure out what's going to happen. So what this deck does is creates this array right here, which I would like this to become create the table deck. Create, this is what I want to add here, create the table deck of 0s and 1s. Now the table deck is going to be identified by the table, which I have not set here. So as you can see, we have an array subset that we need to consider, and this will depend on where are we in the game. So we're either going to be in the hand known as the pre-flop. I'm calling it hand here. I should call it probably pre-flop, flop, turn, and river. Flop, turn, pre-flop, turn, flop, turn, and river. The pre-flop I'm calling hand. Flop, turn, and river. There we go. This is the original numbers. Now we know the hand is the first 2 numbers. We know the flop is the next 3, 1, and 1. So when we take this array in, and let's go ahead and do that. I'm going to make some space in here. Actually, I'm going to make some space above because we are going to be working here a lot in the next couple episodes. There we go. So how do we do this? Prep the table, basically. The table is going to be flop, turn, and river based on where we are in those systems. So we could be at basically step 0, step 1, step 2, or step 3. In step 0, we're doing the hand. Actually, there's a step 0 where there's nothing. How about that? Step 0 is prep work. Then you have hand, flop, turn, river, win. Those are the 5 cases. So I will create a case structure. This case structure will be based on, I would like it to be based on a number, which we shall get what this number is later on. The number 0. The number 0 implies there is no work being done. Therefore, nothing should really process, but we'll work on that later. So how do you prevent things from being processed? Well, that's a very easy thing to do, or so you think, right? So basically, if this here has no values, nothing following that will process. Therefore, what we will send is an empty array. Initialize an array, dimension size 0, filled with, it could be filled with 0, that's not a problem. Basically, nothing. This array will need to go out and basically connect to the world. We're not using this system anymore, now we are using this. This is our case system instead of using this here. So there we go. In a 0 scenario, nothing happens. Oh, let's make this case 0. Let's take this out of here, put it here, throw it in there. There we go. We have case 0. In case 0, nothing occurs. In case 1, this is the hand. In the case of the hand, what we will do is we shall index this array right here, to get the hand. The hand is this is array subset, is it not? Yes, array subset. So the length we need is 2, and what we get out of this is going to be only the hand. But we're in case 0, so when I run this, everything should zero out. Nothing should really process. Seems that something is processing. Whoa, my laptop's going off the hook. I have a second monitor and I'm monitoring my CPUs. And right now they are all operating above 90%. Okay, they're going between 80 and 90%. That is insane. They're still running at that high. Anyway, so as you can see, everything has zeroed out, except the ones which were the initial prediction, the prediction step for those three, which cannot be altered. So this here, we can alter some things, but we can't alter everything, because this is the deck of 52 cards, and that will always be there. So let us go ahead and convert this into a, well, let's keep this as a 0 right now, just to complete testing. In the case of the hand, we're going to have two things go on, right? So here, we have two known and two unknown. So now I'd like to process the two unknowns, and those two unknowns will need to be a variation of what is going on here. So this here eliminates the known cards and reshapes the deck to one dimension. This here preps you for the player's cards, right? Not for the other's cards. So the player's cards, we do need this. Actually, I'm thinking about this now. We needed this all the time. By knowing we have those two cards, we know that the other person definitely does not have those two cards, so they need to be eliminated. This step does not change based on our two known cards. So our two known cards will always need to be there. This is actually a very interesting thing that I just realized again. I know I did this before, and I'm sorry about that, but there's a lot of confusion going on here. So step 0 is prep, nothing should happen. Step 1 is the hand, gives us the two hand values. Let's add a case after this. In step 2, we have the flop. Now in step 2, here, we're taking an array subset for the flop, which is basically going to give us the hand. This is the hand, and the table to flop. This is interesting. Maybe we can alter this system in order to give us what we want. I'm not sure. Now I'm thinking about this. Oh, this is very, very complicated now, isn't it? So we can have a system of true or false to detect this, and then we would have an alternate system to basically always predict this hand. The hand will always be the first two, and then the next step here will basically give us these numbers from index 2 towards, depends on the length. If it's a flop, it will be 3. If it's a 2, it will be 3. If it's a 3, it will be 4, and so on. So the only number we're changing is this number here. In the hand, this number would be 0. In the flop, this number would be 3. In the turn, this number would be 4, and then 5, basically. This needs some thinking, guys. To make this intuitive, this needs some thinking. So basically, I set up a prep, hand, flop, turn, river, and a win. What I need to do is basically have an on or off first. So let's go ahead and create an on or off. True is on, false is off. That's a constant first. True, this is false. False means the system is off. If the system is off, then the only thing you're gonna get is this. Basically, you get nothing. Now that I think of it, if the system is off, nothing else should process. We don't even need an on-off. I know, I'm contradicting myself. So here's what we do need. We need a system 0, 1, 2, 3, 4. I know, I already said that. But the only difference that we're going to have is going to be this number right here. We don't even need the entire structure. There we go. Basically, this is all we need. Right here. Where this number here should be determined by the value of our case. That's what this should be. So let me see, how small can I make this? That is probably the smallest I can make this. In case 0, which means the hand, I want nothing. Let's make this case 0. Case 1, let us go ahead and delete this case, so case 0. Then let's duplicate this to get case 1, which is the flop. Let's duplicate this again, and this would be 4, and duplicate this again, this would be 5. There we go. So hand, flop, turn, river. Let's adjust for this. There we go. Those are these 5 numbers. 0 gives us 0, 1 gives us 3, 4 and 5 give us 2, 4 gives us 2, 3 gives us 5. And let us go ahead and see whether this worked or not. That's interesting. So going from our initial numbers, let's run this and see what happens. Since we are in a case 0, 2, 10, 4, 10 are the hand. If we go to a case 2, 0, 1, 2, so let's go ahead and add those numbers in here. So 0 is the hand, 1 is the flop, 2 is the turn, and 3 is the river. There we go. So now let's try 2. In 2, that means we're at the turn. We should get only 4 numbers. There we go, till 207. And if we go to 3, we should get 5. Perfect. That's exactly what we want. For now. This is going to get far, far more complicated in a few seconds. So I'm going to leave this on the side now. I'm going to have to ignore everything we have done down here because we're going to have to change some things. Now, elimination. Depending on where we are in the game, the cards to be used will be a combination between this and that. So, contrary to belief, we're going to have to recombine these two and get a subarray that includes all known cards. Let's go ahead and see that. In this case, we know 7 cards. If we go to option 1, we now only know 5 cards, and so on and so forth. Now, this here, this specific thing right there, will need to be the combination between eliminate known cards from deck, reshape the deck to a 1 dimension. That's what this does. Knowing we have this card ensures that ensures that this specific card should not be used anywhere else. Now create the table deck of 0s and 1s right? So now the table deck is now created from the table itself only. Only being the key word right now. This here is our standard deck. For the time being, we don't need to see it, but I'm gonna leave it there for now, just till we have figured out all these small kinks of what's going on. I'm going to also condense this a little. There we go. So this right here, eliminate known cards, is going to come from this array right there. So what I would like to do is delete the input to this and the output to it, and have this sit somewhere over here. The input is this, which are the known cards, and this input needs to come here and input itself into the card generation. So that's what's going on here. Okay, so the next step, so this is our known cards. So we eliminate all the known cards, the cards that we do know, from whatever we are going to generate next. While here we use the table. Let's go ahead and save this for now. Alright. So now, before coming to this analysis step, we're going to have to do a couple things. A couple things. By breaking up the system the way I have, having two unknowns, that means the number of unknowns, this we will not do. This will not do, right? We're not going to do a 5. So we're only going to need 0, 1, or 2. Now there are two unknown hands. Therefore, a 3-card combo system that we have created, we ironically do not need this system, because this system is not going to work the way we want it to. So a 3-card combo deck is not going to work. I'm very hesitant to get rid of it, but I will for now. If we need it, I'll find it in a backup and come back to it. But for now, I'm pretty certain we do not need it. So what do we need? Here is our table deck of zeros and ones. Again, this is the table deck. Now, this here, the table deck, we could have it run twice. One output is going to give us the player deck. One's going to give us the other deck. So the player deck will basically include only the known cards. I'm actually looking at this and trying to think about this again. This create decks for zeros and ones for analysis. We could actually use this system instead of this one, which is basically, as you can see, they're the same system, just minorly different. But instead of using a 2-card combo deck, we can use, in this case, we have an entire system set up with all the known possibilities. When we are dealing with just the player, we know those 2 cards, they're right here. We only want those 2 cards. So let us try to see what's happening. I'm going to create a array indicator on this to see what that shows us. That has all the cards. Eliminate known cards from deck. This what remains is the entire deck. The entire deck. Okay, that's not what we need. We need something very similar to however this 2-card combo works. And the way this 2-card combo works, I'm going to create the second one, is that, and I'm going to connect it to the same one for now. The way that this works, showing the indicator here, and let's just run it slow. Well, let's just run it once. It should run really fast. There we go. We have 414, 413, and so on and so on. We only need the first two of those. That is all we need. We need a single created array similar to this one, which only gives us 414 and 413. Now, the deck we do have is this one, 210 and 410. This is exactly what we need. But what we need to do is we need to convert this from a 1D into a 2D acceptable system. That is what this little block does. Now I'm going to repurpose this block. I'm going to put it back here for now and connect it to that. And I'm going to attempt to see what is done here. First of all, that should give us two numbers right there. If this worked, we get two numbers right here. They're coming in horizontally. I'm not sure if this is an issue or not. Let's go ahead and test this. So I'm going to get rid of this, and I'm going to, let's see, array 7. Where's array 7? This is array 7. Array 7 is our array of possibilities, right? So it shows us all the different possibilities. In this case, it is processing the entire 2-card combo. I would like this to now process just that. So let's see how that processes. If the system worked, we should first have, well, we should have all these 5 in there. These 3 are pre-encoded right there, and we added this one to it, which is just the 210. So this here did work, just not the way we wanted. So what we're going to do is take this subarray, which has a size 2 to 1, and we're going to do this as basically 1, 2. Now let's run this again. There we go. These 3 from here are lighted up. Then we added to it the 410 and the 210. Now we have a successful system to process this specific piece right here. And that's the absolute maximum condensate. Oh no. We can do it a little more. Let's condense it as much as we can. There we go. What does this do? This is the player's hand. That's exactly what it is. This is the player's hand right here. This could actually come directly out of here if we wanted it to. So this is the player's hand. Create a 2-card combo deck. This can be called as the other player's hand, so also known as other player's hand. So other player's hand. So we'll see how we need to figure that out. So there we go. Now we have the table deck right here. So I'm going to eliminate this because we no longer need it. This, we no longer need that. What we need is this system, which is simply going to choose what these values are, right? I'm gonna try to do this way. Yes, beautiful. Get this out of the way and try to get this out here. This is the player's hand. This is the table. I'm not sure how to label all this. So this is the table. This is the, let's see what's going on here. Oh no, this is the known cards. This is the table, and this is the hand. So all the known cards probably needs to be processed first, then the table and the hand. I'm not sure how to process this. As you can see, this is getting very jumbled up. We're gonna have to figure out a way to simplify it. But for the time being, using the player's hand and the table, this array 7 now processes basically the hand and the table based on the data that we give it. In this case, where are we? This may later on be added, so I'm going to leave it on the outside. The only thing I need to figure out at this moment is basically where do I want the hand to come out. And I'm gonna let the hand come out right there. So this is the hand and this is the table, and even though these will cross a lot, that is not my problem. So let's go ahead and throw this into a structure of order. This number represents that. We'll come back to that later. I'm going to add a sequence, a frame before that for labeling purposes. And condense. There we go. So what does this do? This will select needed cards. Needed cards. That's literally what it's doing. It's giving us the known cards up here. Let's say select known cards. How about that? That's what this does. And then here it will select hand and table. Hand and then table. I'm gonna just divide this. So this is your known cards. This is your hand and table. And I'm gonna add the word select cards. The known cards are here, and this is what this does. So this selects cards basically. Can we say this? Select known cards. Alright, so we select the cards. The known one goes here to be eliminated from the initial deck, which is then used to create other things. And the hand will go to create the player's hand. This is a small adjustment that creates the player's hand. The table will go to create the table deck of zeros and ones. Now the table deck of zeros and ones then gets updated based on what we need, which basically is either the 2-card combo deck, the other player's hand, or the 1-card deck, which also takes into account, now that I'm thinking of it, this here will need to be based on the 2-card combo again, I believe. So I'm going to leave it for now. We're going to have to adjust it in a bit. I'm going to get rid of known, hand, and table because now we know what everything is. I will leave this though for now. So we can see how complex this is becoming. Very interesting. I actually love this complexity. So the next thing to do is to, I'm not sure what the next thing is. We were doing an analysis over here of Well, this only tells us whether there's a flush or not. Now we need to analyze the flush for a straight. And here we need to analyze a straight. So let's go ahead and figure that out in the next episode. That's what we were figuring out, how to get the highest card, and we figured out that the other prediction has a different hand than your hand. So we need to know whether to use the known hand or the other hand. Well, we're going to have to use one of each for each system. Alright, what I will do is I will simplify this for the next episode, and I will see you guys then. Bye for now.